Okay, so as we're working on solving exponential and logarithmic equations, we can use this with both as we get to those. There will be some that algebraically we're not able to solve with the tools that we have right now. This is one of those examples, and really the only way we can solve it is by graphing. So if you want to solve an exponential equation by graphing, really what are we asking when we're solving an equation like this? We're asking what would x have to be for these two sides of the equation to equal one another. So when we want to solve by graphing, what we do first is we take each side of the equation and make it its own equation, y equals. So we have y equals e to the x, and then we make an equation out of this side as well, y equals 2x squared plus 1. And what we're going to do now is put both of these on a graph, the same graph, and we want to see where they intersect. Because again, what we're looking for is what value of x makes these the same, and an intersection tells us that they're at the same location. So I'm going to go ahead and open Desmos, and I'm going to graph each of these. Okay, so I'm just going to write y equals e raised to the x power. That's one of them. And the other was y equals 2x squared plus 1. So I've graphed both of those, and now I'm going to, so you can see those are the two equations that I have. The blue is the y equals 2x squared plus 1, and the red is the y equals e to the x. And our next job is to locate the places where these intersect. So they intersect here and here. Now we might even zoom out a little bit. I'm going to close this and zoom out a little bit to see if they might intersect any other place. Oh, and they do. Clear up here. Okay, so I have 3 places where they intersect. And when I'm writing down my answer, I don't want to give the y value. Okay, I wanted to know what value of x made the two sides of the equation equal. So my answers are x equals 0, x equals 0.741, or maybe 0.74, and x equals 2.8. So I'm going to go ahead and write those down, and those are my solutions. So my solutions are x equals 0, x equals 0.74, and x equals 2.8. Okay, so again, the steps for that were we made each side of the equation y equals that. We graphed both of those on the same graph, and then we looked for any place where they intersect and just found the x value for that, because we want to know what x value makes these two equal to one another. Okay, let's go ahead and do one more. Okay, so here we're asked to solve the equation by graphing, and if you tried algebraically using all of our tools, you really wouldn't be able to come with anything definitive. So we know we have to use graphing anyways. So again, we take each side of the equation, whoops, and we make it y equals. So y equals 3 to the x, and then we're going to have y equals x squared plus 4. And we're going to open our graphing calculator, and we're going to graph both of those on the same graph. Okay, so here we have y equals 3 to the x power was our first equation, and our second one was y equals x squared plus 4. Okay, we have them both on the graph, and now what I want to do, I can see, and on Desmos, if you just tap, it will show you the intersection. But what I want to do is go ahead and zoom out just in case to make sure that they don't intersect again. And notice they're just getting further and further apart. So I know the only place they intersect is right here, and it's when x is 1.8. Again, just ignore the y value. We're not worried about that. We want to know what x value makes these two equal to one another, and it's when x is 1.8. Alright, so on my work here, my solution is x is equal to approximately 1.8. It did have some decimals after it. I'm just going to round it off to the nearest tenth. So that is how we solve by graphing. This will work with log equations as well when you get to those. When there's some that say solve by graphing, you do the same process. You take each side of the equation and make it its own equation, y equals, graph them, and then find the points of intersection.